Okay, today we'll talk about ebooks and beyond. Our agenda. Our agenda has been designed as a TAR project, an actual TAR project. So our first topic is the target environment, what our audience is. Then we'll talk about our learning objectives, our research question, then the methods of the project to collect the data, to do the actual experiment, then how we're going to assess those results obtained. That will be our rubric and the results, and we'll end up with a conclusion. Okay. The STEM crisis that the U.S. has been facing for years due to the lack of students engaging in STEM subjects and the shortage of qualified STEM teachers cannot be remedied without a sound and comprehensive approach. An innovative learning approach based on 21st technology paradigm shift is introduced today. Our target environment, okay, what this TAR project and this presentation revolves around: first-year students of any major in a junior college taking a survey introductory STEM course. Okay, that's our target audience. Our learning goals: an ability to apply knowledge of mathematics and engineering, and we have a learning objective: evaluate Ohm's law given a simple circuit. Now, two things to point out: that we have a learning goal and a learning objective. The goal is always broader than the learning objective. Okay, so when we talk about learning goal, also known by the way as a student learning outcome. Okay, and the learning objective is more specific. So we say evaluate, okay, Ohm's law given a simple circuit. The second point to point out is, see the letters here in yellow, the letter A. So this is being mapped. So this learning goal is being mapped to the engineering ABET criteria. And here at the bottom for our learning objective, the evaluate is being mapped to the Bloom's taxonomy level. Okay, so our learning objective falls within the evaluate level in Bloom's taxonomy. Our research question: does an ebook improve student performance, meaning improve grades, right, in the target of difficulty area, which is in our case evaluating Ohm's law? Okay, very quickly here, target of difficulty. What is that? Well, whenever you're going to try to improve your teaching style, okay, always try to find an area where students are not performing as they are expected, or where low grades are obtained when the students are tested. Okay, and that will be your target of difficulty area. Okay, so in other words, you don't want to pursue, or you don't want to implement technology, or you don't want to do research in an area where students perform very well. No, the target of difficulty is the area where students perform low in a specific subject and a specific subject, etc. In our case, our target of difficulty is when students evaluate Ohm's law. Okay, they don't perform as they're expected. Okay, the ebook that we are going to use for the STAR project is called The Keys to STEM and Beyond. Okay, The Keys to STEM and Beyond is a multi-dimensional ebook for an introductory STEM course that offers students the opportunity to learn through an array of diversified technologies, such as videos, PowerPoints, FETs, spreadsheets, and web-based simulators. That's what I consider learning through diversity, technological-wise, right? There are many purposes why the book was designed or published, and two of them are to relax the students' forced adaptation. Keep in mind that there are only two options, printed books and eBooks. So if we didn't have eBooks, then we had to go to school and learn through printed books. And for many decades, students have been forced to adapt to a printed book, right? To learn through a printed book. So by giving the opportunity, giving the student the opportunity to learn through an array of diversified technology, then we're kind of relaxing that adaptation, okay? And the second purpose is the opportunity to learn through an array of diversified technologies. Okay. Before I move forward, let me show you how the eBooks works. Okay, so this is our eBook, and the keys to STEM and beyond. And how we open the eBook is just through an open software that you can download. Okay, once you download the software to your tablet, PC, or laptop, and you have the digital version of your ebook, just double click on it and it will open the ebook. Now, the diversified technology that we introduce, let me show you how it works. Let's go to page 25 here. Okay, here we go, page 25, and here you have a simulator. If you click on the simulator, opens Java, and there you have it. So you have a battery connected to something, right? And you can interact by increasing the what is called resistance, decreasing the voltage, or increasing the voltages. You can show calculations. You can turn on and off some of the features. You can see inside the battery, outside the battery. You can pause it. You can play anytime. So that's our first dimension, the FETs. This is called FETs, okay? Interactive simulators, which is really cool. And if we move forward, we can go to page 29, and there you have a second type of simulator, okay? This second type of simulator is not a FET simulator, but instead it's a simulator that runs on the browser, okay? So here again we have the Ohm's law, V equals IR, and then we increase the voltage. What happens to the current? The current increases. If we decrease the voltage, we decrease the current, but the resistance doesn't change. What if we change the resistance? See, it changes the current, but the voltage stays constant, and so on. Okay, so this is the second dimension, second type of interactor simulator. And then if we move forward to page 37, on page 37 we have videos. At the end of the chapter, the section problems, 2 videos are given where you can click, and right there, see, we have an actual video solving a problem. Okay, isn't that nice? Isn't that really cool? Okay, so let me get out of here and stop. So that's our third dimension. Now if we move forward to page 95, that's gonna be our fourth dimension. This is actually a spreadsheet. If we click here, we're gonna have a spreadsheet, but I'm having technical difficulties right now, so let me go the safe way, and let me go to a different format of the ebook, which is a Word format, and we can just double click here, and there you have it, the spreadsheet. And this is a great calculator that I designed for the students. For example, if the students perform really well in the projects, let's say they got 98, but they perform low in the quizzes, 40, they can just use the pull down menus, and right away they can see that they grade 78%, which is really cool. So that's the fourth dimension. Then if we go to page 115, okay, here you have see one power presentation, another power presentation, a third power presentation. But if you're just looking at the ebook, all you have is the title of the PowerPoint presentation and a picture. So, but by double clicking, boom, there you have the whole power presentation via team player. You know, every group will have managers on. You can actually see the whole power presentation and then go back to the actual book, which is really cool. So let's go back to our presentation already in progress. The novelties of the book: to ease the understanding of challenging STEM concepts, implement evidence-based STEM learning teaching. How about the cost? $3.99. How about that? Demonstrate how to achieve engineering AVID criteria, and so on. Now, the methods of our TAR project, that means the method how we're going to collect data is through assignment, quizzes, and finals. And an example is given. Given the following circuit, compute the current for that circuit. Okay, so the students have to compute the current either as an assignment, quizzes, and finals, and then we'll analyze the results. How are we going to assess the results? Here's our rubric. It goes from no response to sophisticated response, 6 points, and for each level it tells you what exactly is expected from the student. Like for instance, from level good, 5 points, the student computed the right value for current and show all the steps on how it was accomplished. Okay, the results printed versus ebook. When it comes to assignments, students perform equally. Okay, they got 100%. But when it comes to quizzes, there's a difference of 20%. That's 2 letters, and the results have been normalized. 2 letters for quizzes. For the finals, they went from 70 on average to 85. So there was a 50% improvement in performance for the students when an ebook was used. And this was a group of 46 students, 32 males and 12 females. Okay, and there you have your results. So conclusion: it was demonstrated beyond, right, and through a base evidence and learning through diversity TAR project that the use of an ebook in an introductory STEM course in a junior college indeed improves students' performance in the target of difficulty area of evaluating Ohm's law. That's our conclusion. Further research: implement real-time chapter certification. That means that the students can take care of some of the chapters that will be covered in the class. So for instance, if a students, let's say, read chapters 1 and at the end of the chapter requires to do some type of quiz or exam, the students take the exam, and as soon as the student passes the test, it gets certification for chapter 1. And he doesn't have to worry about that anymore. Isn't that cool? Now, we want to implement educational games, implement real-time community forums, to actually have forums within the book and see if, linked. That would be nice. Customize for any subject on a curriculum. Okay, and there you have your references: advancing learning through evidence-based STEM teaching. That's a class. Second one is a paper. The other one is a class. And the fourth is the key to STEM and beyond. Okay. And this is all we got for you for eBooks. Thank you so much.